Welcome, everyone. Scientists are making breakthroughs in communication, not just between humans, but between species. Dolphins, elephants, whales, and even primates are being studied in ways never before possible, thanks to artificial intelligence. What was once science fiction, speaking with animals, is now a real evolving frontier. AI is beginning to decode animal languages, opening the door to a future where we might one day hold actual conversations with other species. At the center of these efforts is Google's new project called Dolphin Gemma, Generative Echoic Multimodal Model for Animals, developed in partnership with the Wild Dolphin Project. This AI model has been trained on the largest dataset of wild dolphin vocalizations ever collected. Researchers have spent decades in the Bahamas observing and recording dolphin pods, logging not just the sounds they make, but the contexts in which they're made, whether dolphins are playing, reuniting, mating, or chasing predators. Dolphins are known for their rich and complex vocalizations, clicks, whistles, and burst pulses. These are fast, high-frequency sounds that travel underwater in all directions. AI models like Dolphin Gemma are now being used to find patterns in this acoustic chaos. Just like language models predict the next word in a sentence, Dolphin Gemma predicts the next sound in a dolphin vocal stream. This predictive modeling is crucial because it allows AI to hypothesize structure, grammar, and potentially even meaning. One stunning breakthrough came when researchers used a wearable underwater computer called CHATS, cetacean hearing and telemetry system, paired with a Google Pixel phone. This system plays made-up whistle sounds to dolphins and associates them with real-world objects like scarves or seaweed. When repeated, dolphins sometimes whistle the same invented sound back, seemingly requesting the object. This is more than mimicry. It suggests the beginning of two-way communication. But there's more. Dolphins each have a unique signature whistle, similar to a name. They use these to call each other. AI is now learning to identify and track these individual whistles, allowing scientists to monitor social dynamics in wild pods. With Dolphin Gemma, researchers hope to establish a shared acoustic vocabulary that could be expanded into more abstract concepts over time. What makes AI especially suited for this task is its ability to detect patterns that human ears and brains cannot. Dolphins hear and emit sounds in ultrasonic ranges, and their echolocation gives them a three-dimensional picture of their environment. This kind of perception is entirely foreign to us. AI can bridge that gap. It doesn't need to experience the world the way we do. It only needs data, and it's getting plenty. In parallel, similar research is underway with other species. Elephants communicate using low-frequency rumbles that can travel miles. Whales sing complex songs that evolve over time and are passed between pods. Parrots use vocal imitation in ways that suggest intention. AI systems are now being trained to parse these signals, categorize them, and build interaction models that go far beyond observation. One of the most promising developments in this space is the idea of acoustic image sharing. Dolphins, for example, may be using sound not just as language, but as a kind of sonar-based picture-sharing system. Their echolocation clicks can create detailed images of their surroundings. Some researchers now wonder if these acoustic snapshots are being shared between dolphins, something like spoken three-dimensional imagery. If true, this would redefine what we mean by animal language entirely. Many researchers believe that interspecies AI communication could also play a key role in mental health research, both human and animal. Prolonged interaction with animals has shown therapeutic benefits for humans suffering from anxiety, depression, and PTSD. If AI can help facilitate more meaningful mutual exchanges between humans and animals, new forms of emotional therapy could emerge. On the animal side, enhanced communication could allow us to better understand behavioral stress, trauma, and even preferences in captivity, dramatically improving welfare conditions for animals in rehabilitation, zoos, and aquariums. Another underexplored frontier is the use of AI-assisted communication in animal-to-animal translation. Most research so far has focused on bridging the gap between humans and other species, but some teams are now experimenting with AI systems that enable one species to speak to another, such as helping a dog understand a parrot's vocal signals or allowing captive animals of different species to coordinate through mediated cues. This could open unexpected pathways for cooperative behavior in mixed species habitats, particularly in sanctuaries and wildlife reserves where multiple intelligent animals share the same environment. So where are we on the timeline? As of now, AI has successfully generated dolphin-like sounds that fit into real communication sequences. That alone is groundbreaking. But we're still far from deep conversation. Most current systems operate at the level of word prediction and object association, akin to teaching a toddler their first words. Still, progress is accelerating. With more data, more computing power, and more refined models, true dialogue could begin within the next 5 to 8 years for some species. In the very next decade, we may see field researchers holding structured, multi-concept interactions with dolphins, elephants, and whales using handheld AI translators. These devices would work in real time, mapping a vocalization to its likely intent and suggesting appropriate human responses. In the not-too-distant future, this could expand to primates, parrots, and other cognitively advanced animals. It's important to note that every species is different. What works for dolphins won't necessarily work for elephants. That's where open-source AI frameworks like Dolphin Gemma become invaluable. Researchers studying different animals can adapt the framework to their own data. The goal is not a universal translator, but a toolkit for building species-specific communication bridges. One factor driving this acceleration is mobile hardware. Early animal translation efforts required bulky computers and slow data transfers. Now, phones like the Pixel 9 can run small AI models in real time. This means underwater communication systems, forest monitoring tools, and even drone-mounted listening posts can carry the full power of machine learning into the field, without relying on satellites or internet access. Ethical questions are becoming just as important as technical ones. If animals begin to understand that we're listening and responding, how does that change our responsibilities? What happens when a dolphin asks why its cousin was captured for a marine park? What happens when a whale mourns the loss of its pod due to ship traffic? These aren't hypotheticals. They're real possibilities, and they raise moral dilemmas that go far beyond biology. Equally profound are the implications for knowledge. Animals like elephants and whales have been adapting to their environments for tens of millions of years. They've developed behaviors, migration patterns, and survival strategies that are far older than human civilization. If we can listen, really listen, we might learn things we never thought possible. How to navigate the oceans without instruments, how to sense changes in the Earth's magnetic field, or how to coordinate group behavior across miles. One organization at the forefront of this movement is the Interspecies Internet, a project involving researchers, engineers, and musicians. Their goal is to develop interfaces that match the cognitive abilities of different species, allowing animals to initiate interactions, not just respond. Imagine an orangutan tapping a touchscreen to ask for a certain kind of music, or a dolphin activating a light panel to express a choice. These systems don't rely on language alone. They consider intention, context, and even emotion. And this brings us to a broader question: what is intelligence? For centuries, humans measured intelligence by how closely animals mimic us. But AI is teaching us to see intelligence in new ways, through pattern recognition, problem solving, and adaptive behavior. In doing so, it's opening our eyes to minds that were always there, just hidden behind unfamiliar forms of communication. Some experts predict that interspecies communication could become part of conservation strategies. If animals can express their preferences or signal distress, we might intervene sooner in cases of habitat loss, pollution, or poaching. Communication becomes a tool not just for science, but for survival. Looking ahead, the first widespread animal-AI interfaces may emerge in controlled environments, marine parks, zoos, sanctuaries. But that's just the beginning. As wearable tech improves, we could see hikers equipped with AI earpieces that interpret bird calls, or fishermen alerted by AI when nearby dolphins are signaling. By 2040, we may live in a world where humans regularly interact with non-human species through AI translators, not just as observers, but as participants in shared ecosystems. These exchanges won't look like human conversations. They'll be brief, sensory, and situational, but they will be real. Thank you very much for watching. Please like and subscribe.